many do we have logged in, Kristen?
8 people in addition to the panelists.
Okay, sounds good. Do you know how many we had registered?
25.
25, okay. So we're down a little bit from the first session. Well, to those of you just joining us, welcome. We're gonna give folks a few minutes to get logged in, so bear with us. We'll probably start in a couple minutes here. Does that sound good, Austin? Luyi? Great.
Sure, yeah.
Great, okay. Well, on that note, I think we will go ahead and get started. Welcome to the, I believe, 3rd SRSA virtual session. Thank you for joining us. Today's topic is going to be kind of on entrepreneurship and innovation patenting. We have 2 speakers, Austin Sanders from University of Missouri and Luyi from Oklahoma State University. And we have 2 great discussants. We have Dave Peters from Iowa State University and Heather Stevens from West Virginia University. Before we get started, I just want to let folks know a little bit about interacting with the webinar format we have today from Zoom via Penn State University. First of all, we will be recording. So just so you know, this will be recorded. This will be posted on the SRSA YouTube channel as well as on srsa.org at a later date. And to ask a question during the webinar, please click the Q&A button to open the Q&A window. Type in your question. There's also an option to have your question be sent anonymously and then click send. You can go ahead and enter questions as presenters are presenting, but I, as moderator, will save all but clarifying questions until after the discussant has spoken. So each presenter will have 15 to 18 minutes to present. Each discussant will have a couple minutes to discuss, raise questions, stimulate a little Q&A or some responses on each paper, and then we will address the Q&A. I also, before we move on and get started, just want to put in a plug for the last of the SRSA virtual sessions, which is scheduled for August 19th. And Julie Marshall from Medical University of South Carolina, another SRSA board member, will be moderating that session. And the speakers are Zachary Keeler from West Virginia University and Devin Meadowcroft from Penn State. Discussants are Steve Deller from University of Wisconsin and Logan Thomas from Appalachian Regional Commission. So please mark your date for the August 19th sessions. So with that, I will stop screen sharing. And Austin, you want to go ahead and share your screen? As Austin is getting ready to share his screen, I'd just like to remind everyone that I will let him present for 15 to 18 minutes. And then Dave Peters from Iowa State University will be his discussant. And then we'll go through Q&A after Austin has completed presenting and Dave has completed his discussant comments.
All right, can everybody see my screen?
No.
No?
I cannot. Dave, can you?
Nope, we can't see it yet.
Okay, just a second. All right, now can you see my screen?
Yes.
Okay. All right. Hello, everybody. My name is Austin Sanders from the University of Missouri, and today I'm going to be presenting some of the research that I've been doing with Sarah and it's called Rural Agglomeration: How Does the Distribution of People Across Rural America Affect Entrepreneurship? So just to give you a little background on kind of the idea, where we got the idea for this paper. Both Sarah and I have made observations in the past, just kind of in our experience in rural areas, about how in different places you see different patterns of where people are living. So my personal example, I remember when I was studying in Germany, I would go running and biking in the kind of countryside. And I remember very distinctly noticing that towns were very contained within their limits. And then you would have a mile or two of just open countryside where nobody was living. And then you would have another little town. And I remember asking one of the professors I was working with, or I was talking or had a class with, why nobody lives in the country here. And they just didn't understand my question at all. And then Sarah, talking to Sarah, she's had a similar experience. Her example is always driving home from Missouri to Iowa. Her example is always crossing the Missouri-Iowa border. She would go from Missouri, where you have houses kind of sprawled out along the side of the road on little plots. And then you would go into Iowa, where there are a lot more farmhouses on large lots, and then more people were confined within the towns. And so this just got us wondering, what effect does this distribution of people, this different distribution of people in rural areas, have on the local economy? And for Sarah and I specifically, we were asking the question, what effect does this distribution of people have on entrepreneurship in these small towns and in these rural areas? So to start exploring that, we started looking at the agglomeration economies literature. And for a very quick summary, agglomeration economies almost always refer to urban areas. And they're just describing places where you have a lot of people and a lot of businesses living close together. And there are a lot of benefits that are economic benefits theorized from having these people living close together. So for example, businesses are close to a lot of consumers, people have a lot of job options, businesses share resources, people share resources. And then also there's the idea that ideas spread faster in these dense areas because ideas will spread from business to business, from person to person, from universities to businesses, and so on. And within this context, rural areas are generally thought of as being kind of the other unagglomerated areas. And they're usually referred to as their economies are dependent to a large degree on how close they are to the large agglomeration economies. So what we're doing in this study is we're kind of trying to take that agglomeration economies concept and apply it to a small town to see if businesses in small towns benefit from having people and other businesses really close together, or if they kind of suffer, or if they struggle more if you have people kind of sprawled out all across the countryside and not concentrated in these business hubs. So in order to do this, we came up with a definition of rural agglomeration, and our definition is it's the rural share of county residents living in places with a population of greater than 500, 1,000, 2,500. We played with that lower boundary. So essentially, they're people not living in urbanized areas, not living in places of 50,000 or more, but who are living in towns of at least 1,000. That's the definition we ended up going with. And it's the ratio of those people living in the small towns over the total rural population, again, excluding the urbanized areas. And so here I just have some of the basic summary statistics on this. And like I said, we went with the definition of 1,000 just because based on our priors and based on our experience, both of us believe that a town of 1,000 people is enough to support a few entrepreneurs, a few businesses, and kind of using the Census Bureau definition of 2,500 as an urbanized cluster. We tried it, but we thought it was excluding too many rural areas. So we went with this 1,000 definition, and in 1990, the average level of rural agglomeration was 42% of people in rural areas were living in a town of at least 1,000. And the other 58-ish% were living either in smaller towns or out in the countryside. So next we decided to go ahead and map this to get an idea of how rural agglomeration, what it looks like across the United States. And you can see here, kind of just first impressions is kind of out in the West, you see relatively high levels of agglomeration, which are those blue counties. The dark blue counties are much more agglomerated with over 63% of people living in towns of 1,000. And then the yellow areas are below average, have below average levels of rural agglomeration. So states with high level of agglomeration are Arizona, Wyoming, California, so those western states, and then also Illinois and Iowa have relatively high levels of agglomeration. And then going through and looking at some of the counties with the absolute highest levels, you have a lot of suburban counties which have high levels of agglomeration, probably because they have a lot of suburbs of over 50,000 people. And so there's really relatively few or little area that is rural in those areas. Most of it is taken up by towns, most likely. But there are also some remote rural areas, such as Silver Bow County, Montana, which has a high level of agglomeration because there are physical barriers that prevented people from spreading over the county. So Silver Bow County was a mining county, and there's one mine or one main town where everybody located because of the mines, and then nobody really ventured out into the mountains. So the population is really clustered in that spot. Places with low levels of agglomeration tend to be in the Appalachians and in the South. So West Virginia, North Carolina, Kentucky had low levels of agglomeration. And then if you look at it on a county by county basis, some of the counties with the absolute lowest levels, they tended to have kind of a small urbanized area. So for example, Leon County, Florida, that's where Tallahassee is. And so that county has Tallahassee and then very few other towns and a lot of people living in the countryside near Tallahassee. So it had very, very low levels of agglomeration. What we did after mapping this is we looked at this and we tried to kind of infer what factors were affecting and influencing the levels of agglomeration in the US. So based on kind of the east-west divide that we have here, we theorized that historical settlement patterns, so when the US was settled, apparently has a large effect on how agglomerated the rural areas are. And also when you think of it, some of those places out west, especially in the Southwest, are kind of arid. And so when people moved out there, they probably had to cluster close together to share resources. And then we also looked at those high levels of agglomeration in Iowa and Illinois, kind of the grain belt, corn belt. And so we theorize that in places where you have relatively high agricultural land value, there's probably a lot of competition between farmers and people who just want to live on the countryside for that land. And so it's less likely to be divided into 5-acre lots for people to put one house on because they want to keep that in production. So next, we just wanted to get an idea of how rural agglomeration has changed over this 20-year period from 1990 to 2010. And the answer is it changed relatively little in the US. So the average amount of change for each county was 1% or less. If you look at the map, dark gray is where our place that became slightly more agglomerated. So there is a bit of a trend in the Great Plains and then kind of the northern Midwest, upper Midwest. And then if you go out to New England and the Northeast, a slight trend to being less agglomerated. And this could just have to do with larger population change patterns, people moving out of the upper Midwest and out of the Great Plains and moving to the coasts. And if you look at the dark blue and the dark orange counties, these are the few counties that became much more or much less agglomerated. And most of these have to do with either a city that crossed that 50,000, that threshold of 50,000. So you had some cities that were urbanized areas in 1990, and then by 2010, they lost a couple thousand people, and so they were counted as a rural population, and it became much more agglomerated. There are also a couple examples of places that had changes in the government structure. So a county consolidated and in Georgia, and the entire county is counted as a city, so it's 100% agglomerated, even though it's not actually. It has 3 small towns in the county. So what we wanted to do is get a better idea of what factors were really influencing this rural agglomeration. So we did a basic OLS regression of some of these factors based on what we saw on the map and just based on our intuition of what factors are influencing rural agglomeration. So there are those agricultural land values that I talked about before. Access to transportation networks, we measured this by counties that have exits to major highways and interstates. The idea here is that people will cluster around these major highways because it gives them access to work in a big city a couple counties away, and also it can create more opportunities, especially in rural areas, because you're driving more traffic through your area. Post-secondary institutions we included. So college towns, especially in a rural context, they're going to employ quite a few people and might draw out more people to the city. And they're also going to be drawing students to the area, and some of those students may or may not be counted as residents, permanent residents there. And then we also wanted to get an idea of how your location on the rural-urban continuum influences the levels of rural agglomeration, especially since this is an idea that's brought up in the agglomeration economies literature. So we wanted to see how agglomerated metro-adjacent counties were compared to a metro county, and how agglomerated rural counties were compared to a metro county. And keeping in mind that the metro counties included in here were excluding basically the city population, the urbanized population. So this is rural places in the metro counties closer to these big cities. So we included variables for each of these factors. And then we also had this idea, like I said before, of historic settlement patterns influencing levels of rural agglomeration, and also other policy factors that kind of designate the use of certain lands. So whether it's zoning policies, conservation easements, and national parks, they all kind of designate how you can use this land. And we wanted to get an idea of how this is influencing agglomeration. Unfortunately, it's very difficult to find data on zoning and conservation easements. And so what we ended up doing is using state dummy variables to kind of capture some of these historic settlement patterns and these zoning conservation easement effects. So they are included in this OLS regression, and the results are on the next slide. But what we did find is that, as we expected, higher agricultural land values resulted in more agglomeration because you're confining the people to the towns, kind of keeping them off the farmland. Highway exits, so access to highways, increased agglomeration. Post-secondary institutions, increased agglomeration. And then on the rural-urban continuum, essentially the further you got away from those cities, from those urbanized areas, the less agglomerated the counties became. So looking at this map on the left, the state coefficients and significance, this is showing the results from that regression of all of our state dummy variables. And Missouri was the omitted condition. So all of these states, all of these results are in comparison to Missouri. And the obvious result here is that all of these light blue, bright blue states west of Missouri and north, these are statistically significantly more agglomerated than Missouri. And then you have the bright red states entirely in the east, which are less agglomerated than Missouri. So this suggests to us that these settlement patterns seem to have had a large impact on rural agglomeration. But also, being from Missouri and working at Mizzou, we're very interested in the fact that so many of Missouri's neighbors were statistically significantly more agglomerated than Missouri, because in theory, they would have been settled around the same period. And so we're interested in why Missouri is less agglomerated than, say, Illinois, Arkansas, Iowa. And then the map that is on the right, this is a map of our county regression residuals. So this is the bright red counties are the counties that were much less agglomerated than our model predicted. And the blue ones are much more agglomerated than our model predicted. There's no real pattern that sticks out, no large pattern. I might just say that kind of in the Great Plains right here, our model seemed to struggle a little bit, suggesting that kind of the sparse population out here, our model can really capture those effects. So far, this exploring the influence of these factors on rural agglomeration, we're trying to understand what's causing rural agglomeration or what's associated with it at the very least. But going forward, this study that we're working on, we want to understand how rural agglomeration is affecting rural economies and rural policy. For our study specifically, we're looking at how rural agglomeration and these levels affect entrepreneurship in rural areas. We've done some preliminary tests on this, and right now we're working on an instrumental variable to kind of improve our model. But we're also interested in what effect that rural agglomeration has on issues such as local government finance. So do county governments struggle financially to provide services in counties where people are just spread out all over the place versus if they're concentrated in a couple of towns, because they have to, it's just a larger area that they're providing these services to. And we're also interested in finding out whether rural agglomeration, how that's going to play into broadband as we try and connect rural areas with more broadband. Is it going to be prohibitively expensive to provide broadband to counties where people are so spread out over the county versus in places where most of the population lives in 2 or 3 clusters? So we're still kind of trying to figure out what rural agglomeration means for policy, and also get a better idea of what is associated with rural agglomeration, and trying to develop methods for interpreting how the two interact, the policy and the agglomeration. So thank you very much.
Great.
Any
Thanks,
questions,
Austin.
suggestions?
And Austin, if you want to stop screen sharing so David can share. I just want to put a plug in there for Austin. This was part of his master's thesis work. He defended his master's thesis in May and is starting a new job in the rural economy branch of ERS next month. So with that, we're very pleased to have David Peters, who's a Mizzou alum and a professor at Iowa State University, discuss this paper, in part because a lot of his work relates to the shrinking of rural communities. So we look forward to your comments. David.
You can see them? You can see
Yes.
the slide? Okay. Dual screens. But so first off, Austin, I thought the paper was very well written. I thought the motivation for studying what I would call small business creation and the impact, how that's impacted by concentration of a population at the county level is interesting. I think it's important as as we fall slowly into a recession, as some think, particularly in rural communities where job creation from larger businesses maybe not be as fast. How do you generate jobs? And of course, entrepreneurship or small business creation is a key part of that. So I thought it was very relevant, both in a policy sense and a practical sense. So just some questions on your paper, on your thesis. These are, again, more suggestions than anything. First, you did a very good job of outlining kind of the agglomeration theory and the research. I thought maybe you could have added just a little bit of some of the perils of agglomeration. So if you think of the Rust Belt, so you have this agglomeration within a set of related industries, and that can be very useful in some contexts, but if the economy changes quickly, then it becomes a liability. So this whole issue of specialization versus diversification of the economy. And this is a very, very minor point, but the cluster theory, a la Porter and others, and Phaser, roles in rural regional science circles, how agglomerations are different. And I think, if I remember from cluster theory, that the key is that the cluster provides innovation, gives those firms a competitive advantage over other, more than just kind of sharing resources and knowledge, that there's something else with that. I wonder if maybe a industry cluster approach might be more informative when you're talking about entrepreneurship. And that gets to my second one, is I understand that there's data limitations, but if you look at the research, the theory anyway, the conceptual theory in sociology and economics, Entrepreneurship is quite different than small business startup or small business creation. So Schumpeter talks about innovation. There has to be some innovation, and people aren't entrepreneurs. That entrepreneurship is an act. You take a very Marshallian approach to, sort of the entrepreneur sort of extracting a rent on ability. I think that's pretty standard. Though in the neoclassical, from my reading of it, there seems to be some argument on whether entrepreneurship can exist when economies are on equilibrium. But I think, one neoclassical approach I thought was interesting, that an entrepreneur, can gain economic advantage by managing uncertainty really well, right? So we can manage risk, but uncertainty. So, I think, maybe just some acknowledgement that even though you use the term entrepreneurship, it probably doesn't fit a lot of the, at least in theory, how we define an entrepreneur. It's really kind of small business creation, small business startups, and they may or may not be doing anything innovative. So maybe just a clarification. Of course, that's just, it's hard to operationalize how a firm's being innovative. In terms of your operationalization, I didn't really have any problems with your rule of agglomeration measure. I was just, interested in that you could think about expanding that maybe to employment, maybe using some location quotient, or look at agglomeration on employment by industry in addition to population.
Okay.
Or looking at population in certain age demographics, so maybe 25 to 45, or maybe the working age population. There could be kind of variations, and you could test whether agglomeration of different age groups or agglomeration of jobs in certain industries might drive it. Again, with the definitions of entrepreneurship. So I did have a question. So in the census data, how do they define what a firm is? Is that, especially for your first definition of businesses that started up that had one employee, is that through a survey? Is that through the unemployment insurance program?
It's through the
UI.
Yeah.
Okay. And then the second one I think is interesting, kind of the gig economy workers, people that just have over $1,000 of income. The one thing I worried is that those counts are inflated, because if I'd earn $1,000 or $2,000, I might show up in one year, not in the second year, but then show up in the third year. But just, there's no good way to measure this. I'm taking too much time here, but I'll try to finish up quickly. Some minor things with the methods. Since you're using counts, not the changes, but the rates per population, you might want to explore whether, if that dependent variable is normally distributed or maybe follows more of a Poisson distribution, you might want to consider doing that. I thought maybe adding some state fixed effects, or maybe even a hierarchical or multi-level model, because you might imagine that state policies might either promote or inhibit small business creation. So that might be interesting if you saw some interesting difference with these state fixed effects. Some states were higher than others. That could maybe lead to better refining the model. I think on your one table with the establishment birth rate, your main independent variable, that rule of agglomeration, whether you add or drop the education variables, it really you have this bouncing beta issue. And I don't know, you didn't really address that, and the variables aren't really correlated, so I'm not sure what's going on. Maybe try to explore that.
Yeah, that's what we're working on right now with our.
Yeah, it's because they were pretty large differences. Pretty moderately strong negative coefficients to moderately positive ones when you drop the. So that's troubling. But so one question I had is, you clearly show that the education, particularly education at the higher levels, really is associated with business creation, or what you call entrepreneurship. So that clearly implies that agglomeration is maybe less important, but this education component really is. So I wonder if you could speak a bit about just what does that mean? Is it really education proper? Is it experience? Is education a proxy for education, for experience in an industry, and they go off on their own? Or should higher ed maybe change our various curricula to include entrepreneurship? I just wanted to you address that, and then also whether that's from what you've learned from your thesis, if you were going into a rural community, would you suggest that they really focus on small business creation as a way to generate economic growth in the community, or should some communities stick with traditional business retention and expansion and recruitment efforts? So I'll leave it to you and to respond and for other questions, but thank you.
Thank you. So for the question on education, that was one of the reasons why we included we included the two measures of entrepreneurship. So we kind of used the births, the new businesses with employees as our growth, if you want to call them growth, entrepreneurs. And the idea there was that those positive relationships are because you have people going to college and they know how to make a business plan. They know how to, get their loans and support at least one employee. So they're at least creating one other job and one other person that they're responsible for. Whereas our non-employers, we used as kind of the necessity entrepreneurs, people who are just trying to make extra money or maybe don't have the extra, a traditional employment opportunity. And so there you saw a positive correlation with the low levels of education. So yeah, we are still trying to figure out what all was going in with what all was happening with the education, because like you said, it did have some weird effects with our rural agglomeration when we included it. As far as communities using entrepreneurship to promote development, I think we look at it as in addition to potentially trying to retain larger employers or attract employers, creating a quality of life, even especially in a rural area, even if you're not creating these high growth businesses that are going to employ a lot of people through entrepreneurship. Having a grocery store, having a bakery, having restaurants will keep some people around, hopefully. And also it could make the community more attractive to either consultants who can work from home, or it can make it more attractive to businesses who are relocating managers. We found that has an effect on where large businesses locate, where manufacturers locate. So thank you. Hope that answered some questions.
Thank you, Austin. Thank you, David. Just in the name of time, there were a few questions that came in on the chat, but I wanted to comment while Luyi gets his PowerPoint up. I wanted to comment that Brian Whitaker made an interesting comment that the size of the largest community should be considered in the rural agglomeration measure, whether it's over or under 50,000. So I thought that was a good comment, and I appreciate very much your comments, David, too. So thank you. With that, let's move to paper number 2. Thank you, Austin. Thank you, David. I want to introduce Luyi Han. He is a PhD student at Oklahoma State University, and we're very excited to have him present this afternoon. Are you all ready, Luyi?
Yeah, ready. Thank you so much. So everybody can see my screen, right?
Yes, we see your screen. I'll let you present for 15 to 18 minutes, and then other students will discuss. Thank you.
Yeah. Okay, thank you, Sarah, and thanks everyone. My name is Luyi Han. I'm a graduate student from Oklahoma State University. The topic of my presentation today is the impact of the U.S. shale boom on local patenting. So let's first start with motivation. So as Mogul et al. And Poppy et al., these two papers, they find a sharp decline in both clean energy patenting and startup activity after a shale boom based on cross-country evidence. So as we know, the effects of shale boom may be highly localized. So my paper focus on the regional evidence, and I use the overall patenting. The second point here is natural resource curves refers to countries or areas with rich natural resource have lower economic growth. So this paper tries to provide kind of new evidence using patenting. So the main research question of this paper is, did the shale boom enlarge the innovation gap between shale-rich areas and shale-infeasible areas in the US? The answer is yes, from my empirical evidence. In terms of contribution, to the best of my knowledge, this is the first paper that examines the effects of the US shale boom on local patenting. As we know, patenting is an important indicator of innovation, which may affect long-run local economic growth. So here's a quick preview of results. So the empirical evidence shows before the shale boom, shale-rich areas had a lower level of patenting than shale-infillable areas, and the shale boom increased the patenting gap between shale-rich areas and shale-infillable areas. Let's move to some conceptual background. I have two main points to point out here. So I believe most of us are pretty familiar with shale boom because there are so many papers. So I just want like very briefly introduce the background for fracking technology and the shale boom. I want to discuss the difference between non-vertical drilling wells and vertical drilling wells. So the first point, with the expansion and advancement of fracking techniques, trapped oil and gas in deep shale rocks can be safely and efficiently extracted and produced. And drilling wells constructed from advanced fracking technology are called non-vertical drilling wells. And many literature refer these non-vertical drilling wells as unconventional drilling wells. And before the shale boom, like before the 2005 or 2000, the most drilling wells were vertical drilling wells, and we call them as conventional drilling wells. So potential mechanisms. As I did in the preview of results, I show the shale boom increase the gap between shale-rich areas and shale-infillable areas. So what are the potential mechanisms behind the story? I have 4 points over here. The first point, the shale boom increased opportunity cost of obtaining more education. Hence, local average levels of education reduced, which indicator fuel higher educated people to innovate. And this is widely supported by many literature, and I just list a few papers over here. And the second point is, if the shale boom decreased number of entrepreneurs or business startups, patenting activities may be going down at the same time. And Partridge et al. 2019 paper defined the shale boom decreased the business startups initially. The third point is the shale boom may alter local labor market competition, possibly decrease share of innovative workers. And I actually tested this mechanism using share of creative class workers. So specifically, based on the Richard Florida's definition of creative class workers, I find the shale boom decreased the share of creative class workers. And the fourth point, and I think this might be the main mechanism in the story of my paper, is building a non-vertical drilling well is about 3 times expensive as a vertical drilling well, although the non-vertical drilling well is more lucrative in the long term. So this indicates more capital is allocated in energy sector, possibly crowding out capital in other industries. And also I'll provide some numbers over here to show that energy industry is not a very innovative industry. So if we measure the share of R&D expenditure over the total sales revenue, so across all the industries, so the share is about 2.5% to 3.5%. Manufacturing industry is about 3.1% to 3.9%. Computer industry is about 10%, but for mining and extraction industry, it's less than 1%. So let's move to the data. So I combine several data sources together. The drilling data is obtained from Enverus, and it used to be called drilling info. The patenting information is obtained from the USPTO. The main data for control variables is obtained from ACS via iPumps. Another source of control variables is from the QC EW data. I use this data to control for the non-oil and gas employment. Combining all the data sources above, the main analytical sample is from year 2000, 2015, and contains 705 commuting zones covering the entire lower 48 US states. I use commuting zone because counting might be too small. There may be strong spillovers across counties. So I use CZ as a main geological area. So let's move to the methods and models. I first estimate the baseline two-way fixed effects model. So the dependent variable here is patent intensity, measured as the number of total patents per 100K population in community node C in year T. The main treatment variable is wells density, is new non-vertical wells density, which is calculated as number of new completed non-vertical wells divided by land area in 1,000 square miles. And also I have a bunch of time variant control variables, include demographic, education, industry specific employment variables. Also I include the CZ fixed effects and the region by year fixed effects and a CZ specific linear time trend. I use this term to capture the linear trending effect of the dependent variable, which is a patent intensity. So next, border contiguity. So my argument here is using the full US sample to compare shale-rich cities with shale-infeasible cities may not be ideal, since they may not be a comparable control group. Rather than comparing patent intensity of all the shale-rich cities with cities without any drilling wells, I compare the patent intensity of all the shale-rich cities with their contiguous cities without any drilling wells. So next, the second model estimate is first differencing model. So basically, the first effects model and first differencing model, they are very similar. So one of the benefits using first differencing model is I can include time invariant control variable in the first differencing model. But these variables are absorbed by the fixed effects in the fixed effects model. So specifically for here, the dependent variable is the time difference of patent intensity. The main treatment variable is the time difference of wells density, and also I have time difference control variables. For the time difference, I use different time periods to do the time difference from 1 year to 5 years, because in this way I can observe whether the crowding out effects on patenting is growing or decreasing over years. So in addition, I have urban hierarchy control variables. Basically, I studied from the Partridge et al. 2008 urban hierarchy models. I control the incremental distance to the nearest MSA with the population at some threshold. So my argument here is because the patenting stuff is very human capital intensive, if a CZ is located near some large MSA, this CZ may receive some sort of spillovers from that MSA, and I can use these urban hierarchy variables control for that. In addition, I include the average patent intensity in year 1990 to 1999 to capture the initial level of patenting. So let's look at some descriptive evidence to say the potential crowding out effects. So this figure plots the mean patents per 100K population, which is patent intensity by groups by year. So I have two groups over here. The blue line is cities in the control group. The red line is cities in the treatment group. So cities without any non-vertical drilling wells are assigned as a control group, and cities with at least one non-vertical drilling well are assigned as a treatment group. So we can observe two things from this figure. First, the cities, which is the red line in the treatment group, or we can say like shale-rich areas, they always had lower patenting, lower patent intensity over all the years. And after the shale boom, about 2005, we can say the gap increased over years. To observe the increasing gap more intuitively, I plot the difference in these two lines into figure 2. So this plot the difference. We can see before the shale boom around 2005, the difference is less than 2. But after the shale boom, the difference between the treatment group and control group actually growing over years. So this kind of sheds light on the potential crowding out effects of shale boom on patenting. So let's move to, I also have two maps. So these maps, I plot the mean new non-vertical drilling wells density over the full sample year. We can see most non-vertical drilling wells are located in the energy states, Oklahoma, Texas, New Mexico. And figure 4, I show the map for the patent intensity over the sample year. And we can say for these energy states, they are lighter color, right? This means they have lower patent intensity. So here is the descriptive evidence, table 1. So this table, I show different variable, main training variable, and these control variables were used due to time constraint. I will not elaborate this. These control variables construct as like shift share control variables. Again, I cannot elaborate how I construct it in this presentation today. So let's move to the main results. So here is a baseline two fixed effects. So panel A, I use a full sample. So we can say in column 1, this means higher non-vertical drilling wells density is associated with lower pattern intensity. And in column 2, panel 1, I include a CZ linear trend, and this does not change what we find in column 1. In panel B, I restrict the sample based on border contiguity, and we can say the main results are pretty stable. We still find these crowding out effects. So let's move to table 3. So this table 3, because the shale boom construct a lot of non-vertical wells, but at the same time, there are still many vertical wells are constructed. So the difference between table 2 and table 3 is I only change the treatment variable. I change the treatment variable from non-vertical wells density to vertical wells density. And what we can see here is nothing. So nothing is significant. This means the crowding out effects on pattern intensity is actually coming from building non-vertical drilling wells, but not from vertical drilling wells. So let's move to table 4. Table 4 shows the first differencing regressions. So first of all, we can say from column 1 to column 5, it shows 1 year to 5 year difference. We can see the non-vertical drilling wells density, you can say this coefficient actually become more and more negative over years. This means the crowding out effects is growing from short term, like 1 year, to medium term, like 4 years, and arrived at the peak at 4 year difference. And if we take a look at this incremental distance controls, these are negative coefficients. This means if a CZ is far away from some large MSA, they receive some penalties in terms of pattern intensity. And this is consistent with the urban hierarchy models from Partridge et al. And also we can take a look at the average pattern intensity coefficient. We can say these are positive. This means higher initial patterns in 1990 to 1999 predict higher pattern intensity in subsequent years. So, and also I did some additional analysis. So in this additional analysis, I estimate the baseline two fixed effects, and I exclude, for example, I exclude New York because New York banned fracking in 2014. So I exclude New York, the main results still hold, and exclude California. And here in column 2, panel D, I use the 2000 to 2010 sample only. So here we can say we still find some crowding out effects, but this is in a smaller magnitude. This means the crowding out effects on pattern intensity is not only coming from the later shale boom, it's actually starting from the early shale boom. So that's all the results I have. Let's do a quick summary of the results. So I find higher non-vertical drilling wells density is associated with lower patterns per 100K population. The crowding out effects do not exist if using vertical drilling wells density as a treatment variable. Empirical evidence shows shale-rich areas had lower level of pattern intensity compared to shale-infillible areas before the shale boom, and this gap widened over years after the shale boom. The development of natural resource reduced local patenting, such as that areas with natural resource have reduced innovation and consequently less long-run economic growth. So at least a few points, future works. Actually, I did some of this in my main paper. So for example, the timing of the crowding out effects, is it like lagging effects? And I did something like industry-specific patenting, like manufacturing. Actually, I find most crowding out effects is from manufacturing patenting. And I can use a spatial matrix to measure spillovers directly. So yeah, that's all I have today. And thank you so much. Any questions and suggestions are very welcome.
Great, thank you, Luyi. And Heather Stevens from West Virginia University is going to be your discussant. Heather?
Yeah, thank you.
Thank you, Sarah, and thank you, Luyi. I think this is a very interesting contribution to this literature. It is something different that people haven't explored in terms of looking at the impacts of shale drilling on local economies. And your sort of motivation of it in terms of, is there some sort of resource curse, right, that's crowding out this innovation, is one that I think continues to need to be explored a little bit more. And so with that, you kind of have two motivations that I would like to explore a little bit more. And one of those is this crowding out of education, right? So if we're crowding out education, right, then that could lead to less innovation. And then the other one would be, well, I guess they're related. A sort of second one would be, are we sort of crowding out people starting their own businesses, or are we crowding out other industries, right? So a more innovative industry, right, that would have more patents, or are we crowding out just sort of innovative people or this innovation through people starting their own businesses? So one of the things that I think could be kind of interesting would be to have some, especially when you start doing your first difference models, where you can have these specific controls that don't get sort of absorbed by your fixed effects. And especially since you have, your distances to MSAs are already kind of fixed. Have you thought about controlling for some historic things about these places, right? So are these places that have historically had mining or drilling, right? So this kind of activity that also might crowd that out. Are these places that historically had a lot of big employers, government, manufacturing, also that might have led to lower innovation? And then the other thing you might want to think about is historic education, right? Because if you have, before this whole time period, if you don't have much of an education base, right, then that is going to be something that could hurt you, right? And it's not to say that it'll overturn your results, but what you are kind of lacking here is a real clear mechanism, right? You have these proposed mechanisms, but we haven't been able to actually isolate what that mechanism is. And I think that would be the big contribution, right? So you admit in the paper that, patents is kind of a rough estimate rate of innovation. So if you really want to understand, is this really due to drilling or is it something else, right, that just happens to be associated with drilling, then I think trying to explore those mechanisms further would be very useful. I know you wanted to gloss over those predicted control variables in your talk, and we can talk more offline if you want, but I'm concerned by using predicted control variables and not the actual control variables. That if the actual control variables are very different than the predicted, that you might actually not be controlling for something about that place that's changing over time. And then that could be being captured by your drilling variable, right? So something to keep in mind. And then another comment that I would make is, I know you did all the sensitivity analysis, and I think it's great because your results stay very robust across all of the sensitivity analysis. But I would suggest another sensitivity analysis would be to look at oil versus gas. And because the sort of price mechanism and things like that could be quite different. The cycles are a little bit different as well. So that might be one thing to look at. And then you mentioned in your final slide this idea of you looking at spatial spillovers, and I would strongly encourage you to move from your commuting zone variables to county variables where you then account for the actual spillovers, because I'm kind of concerned that by using commuting zone, you're not capturing where the innovation is versus where the drilling is. So I can think of, near where I live, right? You've got Pittsburgh, right? Which is in the middle of a region that has a lot of drilling, but there's no drilling in Pittsburgh, right? So, and there probably is some decent innovation in Pittsburgh, but when you're grouping it all together with all these other surrounding counties, right? It might look like there's not that much innovation. So I think if you really want to isolate this innovation, we want to look at it at a more localized level where the drilling is actually taking place, and not just this kind of bigger zone where drilling could be in one extreme corner of it, right? And it still might be having an effect, but I think you'll have a stronger case if you still get it when you do that and just account for the spatial spillover. So you'll have your direct effect in that county itself, but the spillover from the surrounding counties as well. And so I have a few other things, but with that, I'm going to turn it over just in case there's any other questions from the audience. I don't want to monopolize the time, but I think this is a really interesting paper, and I think you've got the data to do a lot of the things that I mentioned without, it being a big change in your approach.
Sure, yeah. Thank you.
Luyi, do you have any responses to those comments, or?
Yeah, I think thank you so much, Heather. These are great comments. I think the spatial lags, like I did some preliminary analysis using counties. So I still find something, but I would think about this, like how to building spatial lags at county level. First of all, let's go back to the first, like the predict control variables. So the reason I did predict control variables is due to the data constraint, like the ACS 2001 to 2004, they do not have the Puma information. So I have to use these predict variables for my analysis. But actually I can drop this variable and think about how to include other control variables. And the second one is for the mechanisms. I think this is great. I just tested one mechanism in my paper. So actually I did quite a lot of analysis based on the labor market. But it seems like, to be honest, the effects are not coming from the labor market. It seems like it's coming from the capital market. So I will think more about how to isolate the mechanism and how to test more. And the third point you mentioned is the spatial spillovers, and I think this is great. This is great, and I will do that in my paper, like do the county level and say whether is a crowding out coming from. But I'm a little bit worried about there may be some like commuters. They live one area in one county and they work in another county. So if I do the county level analysis, I may mess up with these commuters. So that's why I use CZ as the main analysis. But absolutely, I would do the county level analysis and say how I control the spatial lags and how the story changes. So yeah, that's my main response. Thank you so much. Yep.
Thank you, Luyi, and thank you for discussing that paper, Heather. I didn't see any other comments coming up in the chat, and we are at the close of the hour. So I want to thank our presenters, Luyi Han from Oklahoma State University and Austin Sanders from University of Missouri. Thanks for tuning in, and please mark your calendar for August 19th, our next SRSA virtual session. Speakers will be Zach Keeler from West Virginia University and Devin Meadowcroft from Penn State University. Thanks all.
Yep. Thank you so much.
Thanks, Sarah.
Thank you. Bye.
Thank you, everyone.
Thank you, everyone.